One of the key ideas we're going to talk about a little bit in this class is the idea of a symmetry. And a symmetry is an example of a rigid transformation that maps a triangle or any kind of figure onto itself. Let's take a look at some examples of what I mean by that. All right, so here we have a square and a pentagon. And if I said, what happens if we reflect this square across this line here? What would happen? And you can imagine that in your mind, or if you've got a tool like this, we can actually see that if I reflect that square across that, this square is gonna be moved. All right, so that is an example of something that is not a symmetry. But by the other hand, if we rotated this square around the center point, and I said, what happens if we rotate it counterclockwise by 90 degrees? The new square is exactly on top of the original square. So that's what we mean by a symmetry. Okay, we can also look at a symmetry in this pentagon over here, but this one is a little bit more complicated. If I rotate this figure around the center point by, again, we'll go by 90 degrees, you're going to see it doesn't line up. So, what is the correct amount to rotate by to have it come out correctly? And it turns out that the correct answer is going to be 72 degrees. So if I put in 72 degrees, that just changed color, which means that the image of this pentagon lies exactly on top of the first one. Let me tell you what happened here. So this angle went exactly to this one went exactly to this one went exactly to this one, and so on around the triangle. So if I create this angle here, how big do you think we're going to find that angle is? Boom, boom, boom. They tell us that the measure of that angle is the 72 degrees. Can you imagine how we could have figured out the number 72 without having to guess it? Or have me tell you what it was? Give that a moment's thought while I do a little extra work here. Well, the way that this works is when we draw the triangle like this, or the pentagon like this, into a set of 5 triangles, you can see that each one of these 5 triangles is congruent to each other. And how many degrees are in the whole angle put together? Well, the whole angle all the way around the circle is 360 degrees. So if we took 360 and divided it by 5, we would get, I don't think you're going to be able to see this, but 360 divided by 5, when I bring that up on my calculator, is exactly the 72 degrees that we were hoping to see. So that's where that 72 degrees comes from. All right, so that gives you an idea. So if we were doing a 9-sided figure, which is called a nonagon, if we were going to rotate that around and find the symmetries of that, how would we know how many degrees to have it rotate by? Well, if we divide 360 degrees by 9, we're going to get 40. So if we rotate it by 40 degrees, either clockwise or counterclockwise, that's going to be a symmetry. And it doesn't just need to be 40 degrees. It could also be 80 degrees or 120 degrees or 160 degrees, but it needs to be a multiple of that key number 40 degrees. So hopefully that will give you some good progress that you can make on the IXL.